Okay, so I'm back again. So we're continuing on the nomenclature of carboxylic acids. So I had already referenced the fact that carboxylic acids take priority over everything. So if you have other functional groups in your molecule, the carboxylic acid takes priority. So therefore, we have to make everything else a side chain. So if you have a alcohol group, it is a hydroxy. If you have a ketone or aldehyde, the prefix right here says it would be oxo. Uh, be very careful that you don't get these mixed up, okay? So it says here that the prefix oxo is usually located in the carbonyl group, the aldehyde or ketone. So if this takes priority, you're going 1, 2, 3. So I know that this is on the third carbon. So what does it end up looking like? Well, it looks like 3-oxo propanoic acid, which I have right here. So 3-oxo propanoic acid. So if I just see a double bond O, it's oxo. Okay. Over here, what do I notice here? Here's my carboxylic acid, so I'm going to number it. I see two things. I see an oxo and I see a bromo. So which one do you think is going to take priority right down first? Well, hopefully you figured this out by now. It's alphabetical order. So what comes first? Bromo does. What comes next? The oxo does. So it ends up being 2-bromo, 4-oxo pentanoic acid, which I have right here. Okay, not too bad. So now what? It says when the carboxyl group is added to a ring, okay, a cyclo. The ending carboxylic acid is used to name the parent cycloalkane. So what I do here, let's use this. My parent is this, which is cyclopentane carboxylic acid. That's kind of nifty, isn't it? I mean, I hope it's pretty straightforward for you. So cyclopentane carboxylic acid. Now I have more stuff on here. So I have a cyclobutane, so I'll have to use that. But here's my cyclobutane. I have a chlorine group and I have a carboxylic acid on alternating carbons. So notice I showed you the wedges with the hydrogens. What am I trying to imply to you if I show you wedges? I'm trying to imply we have to think about cis strands. So where are my H's? They are across each other. So if they are both using, here, let me erase this. If they're both using the wedges on opposite directions, that's a trans. Well, if the hydrogens are trans, then these guys are trans too. So it's, remember how this priority, this is always going to be on the first carbon because it takes priority, 2, 3. Oh, why didn't we put a 1 over here? Because it's the only thing on there, so it will be a 1 no matter what. We have carboxylic acid takes priority, so give this carbon the 1. All right, 2, 3. So it is trans 3-chloro cyclobutane. Oops, I left out the B. Put a B right here, please. Cyclobutane carboxylic acid. All right. So what about the aromatics? Okay, the aromatics, let me pull this up here, are named by attaching the suffix oic acid or ic acid, appropriate prefix derived from the aromatic. Okay, do you recognize this first one? It's one of the design. So it's benzoic acid. Hopefully you recognize that. And well, here's an acid. Do you recognize this? Okay, that was one of the big names too. So that was toluene. So this is on the second carbon, maybe the third or something. It is orthotoluic acid. All right. I probably would have also come up with 2-methyl benzoic acid or orthomethyl benzoic acid. So maybe I'll try to look that up as to making sure why, or if we can use that as well, because toluic acid, I'm not as familiar with that. So let's turn the page and see what we get. Okay, so now you practice this stuff. So I'll pause and then I'll put the answer up, and then I'll pause and put the answer up. So when I am pausing, I want you to think about what is going on here. Just copy down my work. Think about what I'm doing first. Okay? So I will get back to you and after you work on problem A. All right, hopefully that was pretty straightforward. No problem. I have 4 carbons, then roaming off the third one. Now try letter B and think about what that is doing for you. Okay, so pause and draw it out. Well, there you go. Hopefully you recognize that you had a triple bond after the second carbon, and you have the carboxylic acid. So hopefully it's helpful. That looks like a mouthful, but break it down. You know you have a carboxylic acid. You know you have a cyclohexane. You know you have a methyl on the 4th carbon. So think through, draw it all out. So here I have this. I have the cyclohexane. You'll see right here. I put this off the 1st carbon. So here's my 4th one. Notice how my wedges, my hydrogen different, so therefore the methyl and the carboxylic acid are also. Why don't you try D, E, and F, and then I'll have all the answers put up here in a minute. So pause, do them, and then go for it. All right, hopefully that worked out for you. So notice we have a hydroxy group, which is an alcohol group. I also have the methyl right here. The next one, be careful. I have a 6-oxo. It's on the very end. So that would be my aldehyde group. Again, the prefix oxo or the root oxo could either be a ketone or an aldehyde, depends on where it is on the structure. The next one here is my benzoic acid. And then if this is ortho, here's meta, my NO2. Okay, hopefully that wasn't too bad. Next, you get to name these. So why don't you spend a little bit of time and come back and see how you did. All right, so how did I do? So keep in mind this, oops, it's not right here. This is your main chain. Carboxylic acids are never going to be a branch. So here's carbon 1, here's carbon 2. So what's hanging off of carbon 2? A phenyl group. So it's 2-phenyl ethanoic acid. Going down, if this is my carbon 1, remember how I drew that? 2, 3, 4. So it's butene, so it's a 2-butenoic acid. When we have this cyclo group, remember how we did this? It's cyclopropane carboxylic acid. So in a sense, this becomes your branch. We don't make it an O, it's cyclopropyl. It's cyclopropane carboxylic acid. Over here, you have 2 carbons hanging off of your second, 2 chlorines hanging off your second carbon. It's 2,2-dichloroethanoic acid. Very, very similar in letter E. It's 2,2-dimethylpropanoic acid. So if you were to draw this out, by the way, show you this. And notice that this carbon, which is this carbon, has 3 carbons hanging off of it. Okay, so my longest chain is still 3 carbons, so it's 2,2-dimethylpropanoic acid. And last but not least, we have a paramethylbenzoic acid. So again, if this is where my carbon 1 is, this is my carbon 4, or in the para notation. So hopefully this worked for me. If you have questions, write them down and we can go over them tomorrow. But what I'd like you to work on now is the worksheet that follows this one in the packet. So take care. See you later.